Hello, everyone. It's me, Billy Younger, again. This time I'm going to show you something I hinted at before when I was showing you how to do cross products, and it's another way where I use this Levi-Civita pseudotensor to compute by components the individual parts of a curl or a cross product. So this time I'm just going to work out some of the details and show you exactly how that works. So let me get started by turning on my document cam, and we'll discuss it. So this method of actually working out the individual components of a cross product is pretty straightforward, but you have to know something about the Levi-Civita pseudotensor. So the Levi-Civita pseudotensor is normally written like epsilon like this, and it's normally written like epsilon I j k, meaning it has three indices. And then we also use the Einstein summation convention, which says that whenever a subscript or superscript is repeated, then that means sum over all of them. So this Levi-Civita tensor is really just equal to 1, -1, or 0, depending on what the I, J, and K are. So if epsilon I, J, K is equal to epsilon 1, 2, 3, or epsilon 3, 1, 2, or epsilon. Now, in this case, notice I'm just moving them over to the right each time. 2, 3, 1. If it's any of those three, then it's equal to 1. If, on the other hand, it is, let's say, epsilon, and let's trade two spaces. Let's say 2, 1, 3. Or let's trade two spaces here. 1, 3, 2. Oops, left off the epsilon. Or let's trade two spaces here. Epsilon 3, 2, 1. In other words, non-cyclic permutations of this, then the answer is going to be -1. And if any of them repeat, so epsilon I, J, K, this was also epsilon I, J, K. If any of those repeat, such as epsilon 1, 1, 3, or epsilon 1, 3, 1, or epsilon 2, 1, 3, or dot, 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 then it's 0. Okay. Once you have that, then things start to make sense. And the way we can do a cross product is A cross B. That's the actual cross product we're looking for. And we're basically saying that A would equal A1, meaning A sub X, plus A2, meaning A sub Y, J hat, plus A3, meaning A sub Z, and then it times K hat, and B would be defined similarly, where 1, 2, and 3 mean X, Y, and Z. So if I do that and I say A cross B sub 1, okay, or actually, let me go ahead and do the more general. Let's say sub I, then that is epsilon I, J, K. Now, normally, Einstein would require that the summation convention have one indice up and one indice down. I'm just going to stick with it, all of them down, and that'll be fine. What I'll do is now say A sub J, B sub K. That's really the prescriptive formula. So if you want the X component, then you're going to put 1 here and 1 here, and then you'd see that 1, 2, 3, which would be A sub 1, or excuse me, it would be the X component of A cross B, A sub 2, which would be A Y, and B sub 3, which would be BZ. So let me show you exactly what I mean by that. A cross, it's actually a lot harder to say than it is to actually do. So if I want the 1, I know the only thing that's going to survive with epsilon 1 is when epsilon 1 is followed by the subscripts 2 and 3, they would be positive, and 3 and 2, they would be negative. So I'm going to say epsilon 1, 2, 3, A2, B3. Now the other one would be epsilon 1, 3, 2, A3, B2. but this is just 1 and this is just negative 1. So I'm going to say A23 minus A32. Or excuse me, damn it, B3, B2. I've just completely left out the B. So that literally means A, Y, B, Z minus A, Z, B, Y. Let me show you another, this time hopefully not making the mistake of leaving out the B. Let's say A cross B, 2. That's again going to be epsilon 2. But when we get epsilon 2, then I'm going to have only be able to finish that with a 3, 1, and that would be A3, B1 plus epsilon 2, 1, 3. That one's going to be the negative 1. So I get B3, A1 in that case. Or excuse me, yeah, A3B1, B3A1 in that case. I've just put them in a weird order. That's what made me stutter for a second there. So 2, 3, 1, of course, is one of our cyclic permutations. So that's just 1. So I'm going to say A sub Z, B sub Y minus A sub, B3, 1. That was supposed to be Z and, that was supposed to be X. Sorry about that. A sub Z, B sub X minus A sub X, B sub Z. And finally, A cross B 3 would be epsilon 3. Of course, the only cyclic permutation in that case is 1, 2. So that would have to be A sub 1, B sub 2 plus epsilon 3. I reverse those. That's going to be my negative. So I'm going to say 2, 1. And that, of course, would make A sub 2, B sub 1, which gives me, in fact, since epsilon 3, 1, 2 is just positive 1, I get A, X, B, Y minus A, Y, that's A2, B, X. So those are the individual components. And that's just a neat way you can do it. It's actually a lot easier to do it when you're not explaining it. That's why I was making little careless mistakes. But that also allows us to do the curl, because the curl is a del cross, let's say, A. Okay. So what the del is remember the del operator is I hat partial with respect to X plus J hat partial with respect to Y plus K hat partial with respect to Z, which you can also write, by the way, a lot more succinctly by writing it I hat partial sub X. In other words, I don't need to put all that whole fraction in there. I can just say partial sub X. I can also do J hat partial sub Y, and I can also do K hat partial sub Z, which in our terminology of 1, 2, 3 would be I hat partial sub 1 plus J hat partial sub 2 plus K hat partial sub 3. And then, of course, the AX would be A1, the AY would be A2, and the AZ would be A3. So if I want to use del cross A and find its ith component, then I'd write that again, partial or epsilon sub I, J, K, the Levi-Civita. And by the way, this is that spelling, Levi hyphen Civita, Civita. Pseudotensor, Pseudotensor. Okay, that's what that thing we keep saying is. It's the Levi-Civita pseudotensor. So in this case, we have epsilon ijk. Then we have to have the first part of the cross product, which is the del operator. So I'm going to say partial sub j, and then I'm going to say a sub k. So now we can say that del cross A sub 1, which is del cross A sub X, that's going to be epsilon 1, 2, 3 times partial to A3 minus epsilon 1, 3, 2, or actually I'll say plus because the epsilon is going to make the negative. Sorry about that. Partial sub 3, a sub 2, which just gives us partial with respect to y of a sub z minus the partial with respect to z of a sub y. Similarly, the partial or the curl of a y component, in other words 2, is equal to del cross a sub y. That again is epsilon 2, and that has to be ended with 3, 1 to be cyclic. So we're gonna say that that's partial sub 3 a sub x minus plus epsilon 2, and then I'm going to flip those two, and it looks like I've grabbed my dead pen again. Epsilon 2 partial, in this case, oh, excuse me, I forgot to write the other thing. It's supposed to flip the 3 and the 1, so that'll be 1, 3. And this will be partial sub 1, a sub 3, which ultimately gives us epsilon 2, 3, 1 is positive 1. So I'll say partial with respect to z of a sub x minus, because the epsilon 2, 1, 3 is not a cyclic permutation, I get a minus 1. And that'll be the partial sub x of a sub z. And then just to finish this off, I have the curl of a, but I want the third component, which again is del cross a sub z. That's going to be epsilon 3, and the cyclic permutation of that is 1, 2. So that'll be partial sub 1 a sub 2 plus epsilon 3, 2, 1. That's the non-cyclic permutation, so that's going to be negative 1. But this is now going to be partial sub 2 of a sub 1. So ultimately, in this case, I get the partial with respect to x of a sub y minus the partial with respect to y of a sub x. And I think you can see that all these components for both a cross b, this one, and this one, and these components for the curl match what we've done before. So the final results, of course, are this for the x component of a cross b, this for the y component of a cross b, and this for the z component of a cross b, and then finally this for the, oops, I missed one, this for the y component, this one for the x component, and this one for the z component of the curl. So hopefully that's another way that you might find useful. I find that way fastest, again, unless I happen to be trying to say it out loud, and then I find myself being an idiot and making all sorts of careless mistakes with things like that, and I just want to punch a baby. Again, goofy humor. But you folks have a good day. I hope that helps you.